Okay, let's take a look at graphing this function here. So again, our steps are to graph out the parent function. We should graph out enough of it so that people can see all that's going on. Now, I'm not going to give you a specific limit like, oh, you've got to graph out to 2 pi or 4 pi. Graph enough out so that it's obvious what the entire function looks like. So here we'll go from -1 to +1. Again, I won't be giving you, will not be giving you the graphs of the parent functions. You have to know what they look like. That includes cosecant, secant, tangent, cotangent, sine, and cosine. So cosine, we'll graph this guy out first. The first function I want is the cosine of x, because that's the parent graph of this guy right here. So we know that cosine starts at a height of 1. It falls down this way, comes back up like this. Again, we try to make it nice and curved, like this. So there's my cosine curve. Again, it extends out like this, and it comes back down like that. Now what we do is we look at the inside. All the stuff that's impacting the variable x before cosine has a chance to act on it. So the things that impact the x are this pi right here and this pi right here. So this pi is the first guy to impact the x. So it's the last guy we're going to graph as far as the inside is concerned. And this guy is the last guy on the inside, so this will be the first. So this is step number 1. So we're going to graph out, our next graph is going to be y is equal to the cosine of x plus pi. So we do this in stages. We just graph each piece that occurs, and we do them in the right order. So what I'm going to do is I'm going to regraph my cosine function. Oops, I want that to be pi over 2. So again, the function that we had before looked something like this. Came up, came down, and like that. So that's our graph up here. Now this pi, well, what it does is, since it's on the inside and it's addition and subtraction, we're going to move left or right, okay, and the opposite of what we'd think, so we're going to move to the left by pi. So every point is going to move to the left pi units. So this guy moves over here, this guy over to here, this guy to here, this guy to here, this guy to here, and of course it would continue like this. Now this looks like we've inverted it, but we haven't. It looks like we've reflected it. This is not a reflection. Even though it looks like that, it's not. It is a shift. So we've got that done. Now we can erase the yellow, and here's our new graph, and this is the blue guy right here. Okay, now let's just get rid of this, and let's move on to the next piece. The next piece is this pi right here. So we'll draw out the graph. And the old graph looked something like this. So I'm going to redraw that guy out. Okay, now what we want to graph here, I'll do this in green, is the cosine of pi x plus pi. So because it's multiplication, it does the opposite of what we would think on the inside. So this is going to be a shrink by a factor of pi. So the guy that's at 0 stays at 0. The guy at pi over 2, now this is where it gets interesting. So let's make a little chart over here. The guy at pi over 2 is now multiplied by 1 over this number out in front, 1 over this guy right here. So this just gives me 1 over 2, or 1/2. So the guy that was at pi over 2 is now at 1/2, not 1/2 pi, just 1/2. Now remember, pi is 3.14. So pi over 2, in terms of a decimal, that's 3.14 divided by 2, which is 1.57 approximately. 1/2 is 0.5. So this guy moves to about here. This is approximately 1/2. Now let's take a look at the next one. So this guy moved back to here. Now let's take a look at pi. Well, pi times 1 over pi is just equal to 1. So that guy moves all the way back into here at approximately 1 over, which is right about here. And now 3 pi over 2 times 1 over pi is just equal to 3/2, or 1.5. So it's really, really close. So this guy moves right back to almost here. Now 2 pi, so far we've got this, and 2 pi times 1 over pi is equal to 2. So that guy's right about here. So that occurs right about here. Now, of course, going back the other way, it'll have the same look to it. Now, so that we're very aware of where these guys hit, we're going to change our scale. So I'm going to delete this blue stuff. I'm also going to change my scale down here so that everyone knows what these values are. So we are going to write down, and you'll do this on the test, we'll write down what each of these marks happens to be. So let me make a brand new clear graph for this. I'll try to keep it so it looks roughly the same. We know that we need to go over to 1/2, then to 1. Now it's going to be just a little bit bigger here, but again, the scale is what's important here. And then it's going to go to 3/2, okay, and then to 2, and then to -1/2, and -1. So we know at 0, it's at a height of -1, which we need to label that on there. At 1/2, okay, at 1/2 it's at a height of 0, and at 1 it was at a height of 1, which we need to label on here as well. At 3/2 it was at 0, and at 2 it was at -1, and of course back here and here. You have to change your axis system so that we know what we're looking at. Okay. You can't, even though I eyeballed these pieces in here, I have to change the axis system so someone's completely aware of where these major points on your graph are at. If you don't change the axis system, it's wrong. And I'll mark it wrong. Okay, so this right here is the cosine of pi x plus pi. Again, we are getting these numbers by taking the originals on the blue, like pi over 2, and multiplying them by the reciprocal of this number. And that's where we were getting these guys out. So they have the same height values, just different x values. Okay, now what we need to do is since we've done everything on the inside, now once we're working on the outside, we don't go in reverse order anymore. We look at what impacts this thing next. Well, the next thing that impacts it is 4. If we're working on the inside, we start with the 1. When we work on the outside, we start with the first thing to impact. So on the inside, you start with the last thing to impact. When you're on the outside, you start with the first thing to impact, which is the 4. So now what we're going to graph out is going to be y is equal to 4 cosine pi x plus pi. And one of the things that I should point out here for you, in case you didn't see it, is that by putting this pi in front of there, we changed the coordinate system here to be nice numbers. A half, 1, 3 halves, 2, nice numbers. Not weird numbers like 3 pi over 4. Okay, so nice rational numbers is what we did. That comes in handy when you're trying to mimic or trying to draw out a graph that's representing behavior in which it happens at nice integer values. So this right here takes a graph that normally was at a height of 1 and -1, and now it stretches it up to a height of 4 and down to -4. So all the points that are on the axis, they stay exactly where they are. Okay. So if it's at a height of 0, it stays at a height of 0. Okay, so these guys right here, this is -1, -1 half, a half, 1, 3 halves, 2. This guy was at a height of 1, it's now at a height of 4. This guy was at a height of -1, it's now at a height of -4. Here and down here. So what we see occur is that we get a vertical stretch by a factor of 4. It's on the outside. It impacts exactly the same way as what you would think. So we multiply by 4, it stretches by 4. Now the last thing to do is add the number 1 to every y value. So the last graph looks like this. So let's redraw out the graph. Try to get them both to fit here on the same screen. So normally, with this purple graph right here, so we're down at -4, we're up at 4. -1, -1 half, it's 0, 1 half, 1, 3 halves, 2. We had a graph that looked something like this. Okay. Now, by adding the +1, what we have is the following. We have y is equal to 4 cosine pi x plus pi plus 1. So this 1 is on the outside, so it is a vertical. And when we add 1, we move everything. It's a vertical shift or a vertical movement of everything up by 1 unit. So this now goes to a height of 5, this to a height of -3. So we're up here. This, instead of happening at 0, now happens at a height of 1. This guy here, this guy here, this guy up here, and up here. So what's happened? We have moved every point up by 1 unit. And that is what's going on here with that 1. Everything got moved up exactly by 1 unit. So we did a vertical shift of 1.